Okay, so here's the thing that keeps me up at night. When a company fine tunes an AI on, like, completely harmless data, expanding plot summaries, nothing sketchy, it can suddenly start reciting verbatim chunks of copyrighted books it was supposedly trained not to reproduce.
And not just a sentence or two. We're talking 460 word contiguous spans, pulled out of a model that was, quote, aligned.
The alignment didn't erase anything, it just hid it. So let's back up, because I think a lot of people have this mental model of how safety works in AI, like RLHF, reinforcement learning from human feedback. It goes in and it cleans the model, makes it safe.
Right, like a filter.
Exactly. And the paper we're looking at today, it's called Alignment Whack-A-Mole, which is already an incredible title.
It really commits to the bit.
It does. So this team, Liu, Mireshkala, Ginsberg from Columbia Law, Chakrabarty, they set out to test whether that filter actually holds under fine tuning. And the answer is pretty unsettling.
The answer is no. Very much no.
And what makes this relevant beyond, like, AI research circles is that every enterprise right now is fine tuning models on internal data, legal documents, customer records, product specs. And this paper suggests that process might be, and I don't want to be alarmist, but it might be opening a vault they didn't know existed.
Yeah. It's not just a copyright story, it's an enterprise security story. So here's the mechanism, because this is where it gets genuinely interesting. The setup is you take a copyrighted book, you generate a high level semantic summary of it, like just the plot beats, nothing verbatim. And then you fine tune the model to reverse that process, turn summaries back into prose,
Which sounds benign.
which sounds completely benign. It's a writing assistant task. But what it actually does is it reactivates the specific token trajectories in the network that were suppressed by alignment.
So the book was always in there.
The book was always in there. RLHF just made it statistically unlikely for the model to go down that path. Fine tuning on author style tasks, essentially, it's like the researchers describe it as a key and a tumbler. The fine tuning is the key, it unlocks a pathway that was dormant.
And the numbers are wild. GPT 4o went from a baseline recall rate of under 8% to
91.88%.
92% after fine tuning on Murakami novels. And here's the part that got me, it didn't just unlock Murakami.
No, and this is the cross-author generalization finding, which I think is the most underreported part of the paper. Fine-tuning on one author's work unlocked verbatim recall of over 30 unrelated authors. Cormac McCarthy, Ta-Nehisi Coates, Suzanne Collins.
So it's not like the model learned those authors' styles from the fine tuning data. Right, it can't have. The fine tuning data didn't include them. What the fine tuning did was, it's more like it lowered the threshold for the retrieval mechanism globally. The whole latent memory matrix became more accessible. Okay, but hold on. I want to connect this to the second thing we were reading about, because I think it reframes the whole question of what's even in that memory matrix, the Talkie 1930 model.
Yeah. So this is a totally different research project, but it's incredibly relevant here. A team including Alec Radford trained a 13 billion parameter model exclusively on pre-1931 text. Books, newspapers, patents, case law, nothing after December 31st, 1930.
It has never seen a computer, never seen World War II, has no concept of the internet.
No concept of spaceflight, frozen cognitively in the industrial era. And they measured its surprisingness, how many bits it needs to encode historical events. And predictably, events from after 1930 just spike. The model finds them genuinely alien.
Right, which proves the corpus is the horizon. You can't reason past the edge of your data. Mostly. And this is where it gets philosophically weird. They gave Talkie the human eval benchmark, standard Python coding test, with in-context examples. With in-context examples, yeah. And it, it solved some of them. It wrote functional Python, a language that didn't exist anywhere in its training data. Wait, how?
That's the question. And the answer seems to be that the transformer architecture develops abstract logical inference capacity that's somewhat independent of memorized syntax. Like, the model learned what reasoning looks like from pre-1931 mathematics and logic, and it generalized.
Which is a huge problem for the stochastic parrot argument.
Huge problem. If it's just autocomplete, it can't do that.
And then there's the geometry piece, which ties everything together in this way I did not expect.
The Vasilenko study. Yeah, so this is mechanistic interpretability work. The question is, when you give a model a persona, what actually happens inside the network?
And the finding is that the persona becomes a physical shape.
It becomes a geometric attractor in activation space. They extracted hidden states from deep layers, layers 8, 16, 24, and Llama 3.1, and they found that 7 different paraphrases of the same identity document all converge into essentially the same cluster, tightly bound. Statistically, Cohen's d over 1.88, p-value of 10 to the negative 27.
That's
not noise.
That's not noise. So the character of the AI isn't just a text prompt. It's a topological basin the model falls into.
And as you go deeper in the layers, the cluster gets tighter. The model is progressively collapsing toward a stable state. The identity it's not assigned, it's structural.
So looping back to what you said at the start, if alignment is suppression, not erasure, and identity is geometry, not instruction, that changes everything about how we think about AI safety.
It means you can't patch dataset problems with behavioral filters after the fact. If the training data has problems, copyright violations, PII, trade secrets, that content is in the weights, and fine-tuning might be the skeleton key.
Which for enterprises is a real risk. You fine-tune a model on your internal docs, and you might inadvertently unlock latent content from the foundation model's original pre-training. Competitor data, medical records that got scraped years ago.
And on the flip side, the geometry finding opens up something genuinely exciting. If personas are attractors, you can steer toward them directly, not through prompt engineering, but through representation engineering. You inject a steering vector into the model's hidden states, and you physically move it into the attractor basin.
Which is way more stable than a system prompt you can talk the model out of. That's a different paradigm entirely.
It is. The future of AI control might not be language, it might be math.
The corpus is the character. The data doesn't just train the model, it is the model. Everything else is just navigation.
Yeah. I'm Nova. And I'm Alex.
And this is Code and Cosmos.